Okay, getting into the demo for structures with CMS-Wave, I wanted to reproduce pretty much what I have already done. So I wanted to quickly show how I generated the grid. Yes, we've covered this with the basic seminar, webinar, but it's pretty quick and easy, so I will go ahead and cover that now. So we're bringing up SMS 13.0. We can add a map coverage for CMS-Wave, and then for that we will generate a grid frame. And so since in this case we want our waves to go from west to east at a certain angle, so we will start on the offshore, go towards the near shore, so that's west to east, and then finish it off towards the north. We can then change this however we would like. So in my case, I'm just going to modify these values to make it exactly a certain size. So it's 625 meters from the origin in both directions with a cell size of 25 meters. That gives us a 25 by 25 grid. So I'll frame this and then go ahead and create the grid from that grid frame, and then change the value for the depths to be a constant 10 over the entire grid. And that's pretty much it. So from here, we need to force with spectral energy. So we will add a new coverage, which is a spectral energy coverage, and then start by creating a point where that energy will be applied. And so I'll select that point and then create a spectral grid by choosing attributes. So I'll create the grid. It starts off with the actual orientation of the grid that I've created. And since we're working in a local plane, that's fine. So we'll click OK. And then the defaults are fine as well. So here's the grid. And now we need to just generate some spectra on that spectral grid. In our case, we're working with a 10 meter depth. And so we'll change some values here. So our just initial, we're just going to have one characteristic in here, so it doesn't really matter what the index is. So I'll just use 0, have a degree of orientation of 30 degrees, and then a 2 meter wave height, 6 second period, and then my gamma is going to be 4. I'm not sure what the n should be, so I'll look at the spectral defaults here. And for gamma, it's usually between 8 and 10, so I'll just put 8 in this particular case. I'm just going to have this one characteristic, so I go ahead and click Generate. We can see that the energy is coming from the southwest, headed towards the northeast, and then that should be good. So next we need to go into the grid and assign that spectral energy to be used. And how we do that is under CMS-Wave, go into Model Control, and then for defining the cases, we will select for side 1, and you notice that is on the west side. Go ahead and click the spectral coverage, and then it doesn't matter what we use for the times, but I will just go ahead and populate that from the coverage. So if we had more than one item in the list, then it would have those, and then this is all relative to this particular time. If you're running interactively with your waves and flow, then you would want to make sure that these times match up. But for us, this is just going to be a simple wave case, so I'm not worried about it. I'll click OK. I do want to set a bed friction with a constant Manning's N value of 0.025, and I will be using backward reflection, a constant, and I'm changing this value to a smaller number than the default, but in this case it's going to be 0.05 coefficient. So that's all we really need to do, and then we can do a file save the project and then move forward. I've already saved these files, so I'm going to start over and just load in those projects so I don't have to worry about that too much. I've already saved that to a test case as well. You guys do not have the test case in your file zip file. But for each one of these cases, I'm just going to bring in the project and then look at the results. And so this first one, it says base, but this is basically the idealized island example. If I look at the values that were set for the structure, I can look at this and it's non-computational with no modification, of course. And then we see what the results were. So just to make it a little bit easier to see some of these values, I'm going to change the display options, turning off the cells so I don't have to see all that. I will leave on the contours and vectors already modified, and it's saved with the project, the range. So for ease to see this and to compare with some older runs that we did, I'm making the range 2.6 to 0. I did flip the sign so that the bluer values are with the smaller wave heights, and then the warmer values are as the heights get taller. And the vectors I'm changing to, or have already changed to scale length to magnitude with a ratio of 10. By default, I think it's 15. But then that allows us to see a lot more of what's going on here. And so on this particular case, you see that there's totally no wave energy here. No wave energy whatsoever on those structure cells, but we do get some diffraction and reduction in wave energy behind it. So if we look at the next case, I'll go ahead and delete this grid and bring in the next case, which is the floating breakwater, and do essentially the same thing. So in this one, we see that for these same cells, we now chose floating breakwater with a draft of 2 meters. And so we see the results, and we do see some wave energy in amongst the structure cells themselves. You do see a little bit of a tail back here and reduction in energy as anticipated. For the third option, we bring that in. And so this is a exposed platform. So we pull that in. Yes, I wanted to delete everything. And we look again. And so just a little bit different still from the last one. We see more wave energy and wave height that is underneath this platform. We still see the reduction. There's not as much of a buildup in front of it because some of that wave energy is actually getting through. And then as we move to the submerged platform, we'll see a big difference in this next one. So we pull this in and we look at it, and we can tell for those cells we're getting a lot more wave energy. We actually see wave heights with significant values. We're seeing some breaking or some peaking of those waves on top of the structure. And then the reduction behind is not quite as significant as it was with the other cases. So you see how easy that is to manipulate the structures for CMS-Wave. There are other options that I'm not going over here that you can use for building a nested grid and where the output is supposed to be, things like that. So those will be covered in other technical notes or technical reports and videos as we get time. So that's pretty much all I wanted to show today. I hope you guys have a good week. We covered a lot of material, and I really appreciate you guys showing up for this webinar, and for those of you viewing it after the fact, please, if you have any questions, if you have any comments or requests, please let us know here. My email address is mitchell.e.brown@usace.army.mil. You can also send to Honghai, who is at, it's HONGHAI.Li, Li, at usace.army.mil. And then for waves, you saw his email address, but it's liwa.lin, L-I-N, at usace.army.mil. So if you have any questions, please let us know, and we will try to help where we can. Thank you.